Problem 713. Airbags are used in cars to decelerate the occupant slowly when a car is suddenly decelerated in a crash. That's what saves your life. Compute the work done by the decelerating force acting on a 55 kg driver if the car is brought to rest from an initial speed of 20 meters per second. Alright, so if the passenger is initially moving to the right, 20 meters per second, let's just symbolize that with V0. So there's a initial velocity of V0, and then there's a final velocity of Vf, which is 0 meters per second. And during this motion, there is a displacement from left to right of delta x. And the agent which causes the deceleration is the force of the airbag on the passenger, which is in this direction. We'll just call that F. And so you can see that delta x and F are anti-parallel to each other. The force is going to be negative. Cosine of 180 is -1. So we can use the kinetic energy work theorem to conclude that the work done by the airbag, I'll just call that W, is going to be the change in the kinetic energy of the passenger. So in other words, it's going to be the final minus the initial kinetic energy. So final kinetic energy is 0 joules. Recall, kinetic energy is 1/2 mv squared. Final is 0 meters per second, so the final kinetic energy is going to be 0 joules. And the initial kinetic energy is 1/2 times the mass of the passenger, 55 kgs, times the initial velocity, 20 meters per second. Subtract. And the number that comes out is minus 11,000 joules. And if we write that in scientific notation, that's minus 1.1 times 10 to the 4th joules. 1, 2, 3, 4 joules. Okay. Part B now asks us to calculate the minimum thickness of the airbag if the average decelerating force is not to exceed 8,900 newtons. You want to keep this force as small as possible because that force is going to act directly on the passenger. And if it's a big enough force, the passenger is going to be seriously hurt. And so there's a trade-off in the design of an airbag between keeping the thickness of the airbag small enough to fit inside the envelope of the car, and balancing keeping that small against keeping the restraining force less than a certain amount. Clearly, because of the kinetic energy work theorem, the thicker you make the airbag, the smaller you can make the force, because the work is going to be affected, force times distance. Okay, so essentially this second part is quite easy. What we'll do is we'll take this 8,900 newtons force and understand that it's going to act over a distance of 0.8 meters, that's the distance that the center of the car moves, plus the additional distance, delta x, that the airbag moves. And that is going to be equal to the change in kinetic energy, which we've already calculated up here. 1.1 times 10 to the 4th joules. Notice I've dropped the minus sign. Really and truly there's a minus sign on both sides of the equations here, and I've let that slide. Cancel out, in other words. And so I can now solve this equation. 0.8 meters plus delta x is equal to 1.1 times 10 to the 4 joules divided by 0.9 times 10 to the 3 newtons. That turns out to be 1.236, 1.24, let's call that, meters. And so delta x is equal to 1.24 meters minus 0.8 meters. In other words, it's equal to 0.44 meters. That's the minimum thickness of the airbag in order to achieve the design goal here.